Cramer's rule states that if we have a system of linear equations with n unknowns, and the determinant of the coefficient matrix is not equal to 0, then the system has a unique solution, being x1 is equal to the determinant of the matrix with column 1 replaced with this right hand vector b on the determinant of the coefficient matrix, and similarly x2 is the determinant of matrix A2, where A2 is the matrix with column 2 replaced with this vector b, and that's divided by the determinant of A, and this continues on and on to the nth unknown, which is equal to the determinant of matrix AN, where the nth column is replaced with the vector b on the determinant of the coefficient matrix A. So let's show this for our system here with a 3x3 coefficient matrix. So first we determine if this system has a unique solution. So to do that, you calculate the determinant of matrix A. And we'll do a quick cofactor expansion of row 1. So we have 1 by the determinant of the minor, which is 3 by 1 minus 2 by 2. And we subtract 2 by the determinant of the minor, so that'll be 1 by 1 minus 2 by 3. And then we add 3 by the determinant of the minor, so that'll be 1 by 2 minus 3 by 3. So that would give you minus 12. So the system has a unique solution. And now we'll determine the matrices A1. So here we replace the first column of matrix A with the entries in B. So what we have is the second and third columns remaining the same, and we replace the first column with 2, 5, 3. And we'll do the same for matrix A2. So this time the first and third columns remain the same, and we replace the second column of A with the entries in B. And finally, for A3, because we have 3 unknowns, we have the first columns remaining the same, and the final column replaced with the entries in B. And now you can calculate the determinant of A1 using the same method we followed for A. So you'd get 3. And the determinant of A2 can be obtained in a similar way, which will give you minus 27. And the determinant of A3 is 9. So have a go at verifying this yourself. And therefore x1 is the determinant of A1 on the determinant of A, which is minus a quarter, and x2 is the determinant of A2 on the determinant of A, so that would give 9 on 4, and x3 is 9 on the determinant of A, which gives minus 3/4. And you can verify this by substituting these into our system of linear equations to verify the left hand side is equal to the right hand side.